Example number 6. Suppose customers in a hardware store are willing to buy N of P boxes of nails at P dollars per box as given by the following function. Complete parts A through D. N of P equals 90 minus 4P squared, where P is between 1 and 4 inclusive. Part A. The average rate of change of f of x with respect to x as x changes from A to B is given by which formula? So the average rate of change is the same as the slope formula. And that, of course, is y2 minus y1 over x2 minus x1. And in function notation, this would be f of b minus f of a divided by b minus a. That's your second y minus your first y divided by your second x minus your first x. There is no limit involved with the average rate of change. Now we're supposed to find the average rate of change of demand for a change in price from $2 to $3. So we're going to go from P is 2 to P is 3. So this is our A and this is our B. So f of A would be f of 2. That would be 90 minus 4 times 2 squared. 90 minus 4 times 4. 90 minus 16 is 74. F of B, in our case, is going to be f of 3. So that's going to be 90 minus 4 times 3 squared. That's 90 minus 4 times 9. 90 minus 36 is 54. So filling in our formula, f of b minus f of a over b minus a. And of course, the name of our function is n, not f, but it works the same way. So it's going to be 54 minus 74 over 3 minus 2. So that's negative 20 divided by 1, which is negative 20. So as the price changes from 2 to 3, the number of boxes drops by 20. Okay, it decreases by 20. So the average rate of change was minus 20. Now in part B, we're asked to find the instantaneous rate of change, first generically when x equals a, and then when x equals 2, or when our price is 2, okay? Price is 2. It's at an instant, not at 2 points, but at 1 point. Well, this is our correct formula for this. We usually have f of x plus h minus f of x over h, but we have to look at it as the limit as h goes to 0. And so this is our correct answer. So doing the instantaneous rate of change for n of p, which is 90 minus 4p squared. Now we have to do f of x plus h minus f of x divided by h. Then we'll do our limit as h goes to 0. So the first thing we need to do is, instead of that p, we're going to need an n of p plus h. So we're going to say 90 minus 4 times P plus H quantity squared is 90 minus 4. This is going to be P squared plus 2HP plus H squared. That's what you get when you full that out. P plus H times P plus H. It's not P squared plus H squared. So be careful there. So it's 90 minus 4P squared minus 8HP minus 4H squared. And that's just the P plus H part. We're supposed to subtract from that the original function n of P. So we've got to get rid of this 90, and we've got to get rid of this 4P squared. Now that's going to be a plus because look, if we're going to subtract 90 minus 4P squared, that's going to be a minus 90 and a plus 4P squared. Otherwise, these don't cancel out. So these are both gone. And I end up with negative 8HP minus 4H squared. And the last thing I'm supposed to do is divide by H. So I'm going to divide this whole side by H. And I get negative 8HP over H minus 4H squared over H. Reducing that, the H is reduced here, and here it reduces and leaves a single H. That gives me a negative 8P minus 4H. So we've divided by H. So we've done the x plus h, the f of x, and the h, but now we need to take our limit. The limit as h goes to 0 of negative 8p minus 4h is negative 8p minus 4 times 0, so it's negative 8p. This is the formula for the instantaneous rate of change at any p-value in the domain. Now our domain is restricted. It told us that we have to be between 1 and 4. Well, and that's fine because this asks us to find it when the price is 2. So remember, our formula for instantaneous rate of change was negative 8 times p. So it's going to be negative 8 times 2 is negative 16. So it's decreasing here. Now, since we have the formula, we can find it easily for price 3. So negative 8 times 3 is negative 24. As the price increases from $2 to $3, how is demand changing? Is the change to be expected? As the price increases from $2 to $3, the demand decreases. Okay, it's negative, it's going down. At the rate determined in Part A, this change is expected because customers are less willing to purchase more expensive items. Now let me go back and fill in these blanks to describe what's happening. This is minus 20 boxes per dollar, because the change is showing us as the price goes up, the number of boxes goes down. So as the price goes up by $1, the number of boxes that it goes down is 20. So it's boxes per dollar. These are also boxes per dollar. Boxes per dollar. So when the price is at $2, our demand, or the number of boxes that can be sold, goes down by 16 boxes per dollar. And at $3, it goes down by 24 boxes per dollar. So our price is in dollars, but it's our boxes that are going down.